At its most fundamental level, memory is an information store. That's why we talk about computer memory. It's a place that you can store your books, films, and even your tax returns so that you can access them again later on. Now, although your flash drive and the memory in your head do the same general job, they work in very different ways. Our memories are not like film or digital media that capture every detail as our senses detect them. Before memories are stored, they go through a process of encoding. The path from information entering our senses to permanent storage in our brains is an interesting one. We have two kinds of memory, long-term and short-term. The short-term memory is the first stop for new information. If the parts of your brain that control memory determine that you don't need memory in the short-term stores anymore, it will let it go rather than storing it. You forget thousands of unimportant things every day. Actually, it's more accurate to say that you never made the memories in the first place. We know for certain that memory is stored in the brain, and we've identified some of the most important parts of the brain responsible for managing memory. But we still don't know exactly how memories work, just bits and pieces of the puzzle. In the past, scientists have described human memory quite a bit like index cards or computer memory, with talk of filing cabinet information, sorting methods we know from everyday life. Today, we know that that's not really how things work. Memory is something that happens throughout the brain. It isn't neatly filed in one particular spot, but different sorts of memories rely mainly on certain parts of the brain. A really cool example comes from research done on London cab drivers. Now, in order to become a cab driver in London, well, at least before GPS came about, you need to memorise vast amounts of information about landmarks, street names, and other details. Scientists have shown that the part of the brain most strongly associated with long-term memory, the hippocampus, is positively huge in the brains of London cabbies compared to the average person. This shows us that our memories are very much a physical thing. The information that we remember are stored in the form of brain cell connection patterns. Just like a computer writes information to a disk, or you would write information to paper, your brain writes your memories in the form of brain cell patterns. Maybe one day we'll be able to read that information directly, like you can read a CD by putting it in a player. For now, the specific brain cell language that memories are stored in remains a mystery to us. Still, we have learned a lot from studying memory and do know that certain things can improve or interfere with the storage and the recall of memories. The exercises in this course take advantage of this knowledge to help you remember things better. We now know that memory is very associative, but what does this mean? Well, it means that a new piece of information that is part of a larger collection of related memories is more likely to stick around in your mind. Here's another weird thing about memory. Have you ever sat in the lounge and thought, I want a soft drink? Got up, walked to the kitchen, and then stood there with no clue why you went to the kitchen in the first place? This is known as the door effect, and scientists have shown that when your brain receives a cue that you have entered a separate space, memories that you formed while in another space may be harder to retrieve. This just shows us another way in which the brain organises memories, and we're discovering more about this process every day. In the next lecture, we'll be looking at assessing your current memory abilities to get a better idea of where you stand and where improvement is needed.